मैंने ग्रुप पे भेज दिया।
Oh,
You basically sent slide it showed that tin के compounds. They are soft, white, lustrous, malleable metals, and they produce a cracking sound called tin cry whenever they are bent. फिर उसके बाद ऐसे उसके properties है. It reacts with steam, then it dissolves in dilute HNO3, then it is rapidly attacked by hot alkalis and slowly by cold alkalis. वो सब कुछ. Uh, that was the last thing that we had written. All of these properties.
okay, Neil, could you please switch on your video better?
Yeah, sure, sure.
Yeah.
Yeah, sure. Now,
Yeah, do the classes like this because then it's better. It's a for eye contact. The teaching will be well.
okay, okay. Just 1 second, sir. I'll just close the window. Yes.
Jyoti ma'am, what happened? Just a minute.
Yeah, sir. No, sir, you're not.
Neil, write in the chat box that she's not audible. Write it in the chat box.
Oh, good.
Some,
Sure.
and yeah, ma'am, you can do one thing. You log out completely and then log in. That might help. Yeah.
Now am I audible?
Yeah, sir. Now you're audible.
Now am I audible? Okay. What I was saying is that yesterday children they gave JE exam and major questions in shift 1 was asked for from periodic classification. And I always lay emphasis on the inorganic. Okay. So
Okay,
whatever
sure.
I'm giving you, they are all IMP questions for NEET. And you have to strictly focus on those questions which I'm giving you. And do it judicially. You will score very good in
Oh,
chem. I am very confident if for NEET. Okay. So what I'm doing is
sure.
I'm sharing you some questions back again and I want you to give me the answer. Okay.
Okay, 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 sure.
I'm opening the whiteboard. Madam, kindly share this again. Madam,
Yes, ma'am. Yes, ma'am.
Neil, kindly solve this for me.
Okay, 1 second.
Recording in progress.
Yeah, ma'am. I've received the photos.
Yeah, please share me the answer.
This I think we have solved already, right?
This was important question. Okay, we'll solve it again.
Oh, okay, sure. It's the fourth option. SN2 plus is reducing while PP4 plus is oxidizing.
Why?
Right. So it is
Why?
because of that inert pair effect I explained yesterday only.
Okay, fine. Now I'm sharing you another question.
Okay. Okay.
These are all, ma'am, please.
Yeah, sir, I received it.
Hmm. Yeah.
It will be the first option, -3 plus 3 plus 5. First of all, -3 because of the 3p cube uh, participation. Then second, +3 plus 5. Nice, sir. 1 second. Plus 3 because of the 3p cube पार्टिसिपेशन, फिर उसके बाद +5 ड्यू टू द 3s² 3p cube participation, and -3 due to gain of 3 electrons.
Okay. So option is A.
हाँ, option A.
Okay. Now see the next question.
Ma'am, second option. The boiling point and melting point increase from top to bottom in the group.
Okay.
Question 7.
Oh, okay. So option is B, right? Okay.
Option B.
Then see the next one.
Yeah, sir, I just saw. Ma'am, option C for the 10th one.
Why?
Basically, option C because of nitrogen's ability to form P2P bonds is correct. First got bismuth's metallic bonds का वो statement is correct. And catenation tendency of phosphorus is correct.
So what is the option?
Option A, C.
Okay. See the next question. Yes, this question.
Yeah, sir, I'm thinking.
Okay.
Teacher, what is pentavalent?
Pentavalent means 5.
Will be option C. Because
Why?
first of all, phosphorus and nitrogen, they are both in the same, they are both in the group 15 of the periodic table. उसके बाद ये phosphorus has vacant d orbitals, फिर उसके बाद nitrogen lacks d orbitals. So the phosphorus is able to produce stable pentavalent products while nitrogen is not. So then
So
ये
कौन
क्या
सा
मैम?
option है? Correct answer?
Option C for 13th.
No. No, it is wrong.
Reactivity of element phosphorus, na?
No, wrong.
Then which option is it, teacher?
See here, we see that because of, 1 minute, because of vacant d atomic orbital, okay, in valence shell of phosphorus, it can achieve the coordination number of +5. But in nitrogen, it is not possible.
Oh,
Now, one more question. See, I'm sharing you one more question. Okay. Now, this
oh,
is, I want a subjective answer for this. Okay.
okay, okay.
I'm not giving an option. Give me a subjective answer to this. Ma'am will share it. Received?
Yeah, sir. Just received.
Yes. Neil, answer please.
Means, do I have to say which valence bond it is, or
Due to the presence of valence bond. See, as we are going from nitrogen to bismuth, okay,
okay,
in the 15th group, see the pentavalency becomes less pronounced, means +5 decreases, and +3 is more pronounced because of the presence of a valence bond. So why it? What is the answer to this? Why? What reason?
basically it is because of the inert pair effect.
Yes. Ha. Good. Fine. Let's move on to our last part. What was left?
इसके बाद तो I don't know. We finished the tin का ये पूरा writing properties
I think I
examples.
no, I think lead is left. Lead is left. तुमने पूरा लिख लिया था पुराना?
हाँ वो लिख दिया मैंने.
Okay. Chloride. Yes. 10 तक पूरा हो गया था ना? SnCl2 पूरा.
हाँ.
Okay. Okay. Chalo, now I'm sharing one more question. I don't think we have done. After this, we'll do more subjective questions. Yeah. Answer this. Yes, what is the answer?
Yeah, sir. Just yeah, +2 and +4.
Why?
We did the sum yesterday. It was because of the inert pair effect which goes on increasing down the group due to the. It was also
Oh.
due to the reluctance of participation of electrons.
Hmm. Okay. Chalo, now we'll start with lead and its compounds. Okay.
Oh, oh,
See, basically, lead, if you see, lead is a bluish gray soft metal. And which is number one, poisonous, and number two, which can cut with a knife, which can be cut with a knife. And this lead actually is pretty unreactive. Then we compare it from its standard electrode potential. And the unreactiveness of lead is due to the surface coating of basic carbonates. Like you can say PbCO3 dot lead hydroxide. So as soon as lead is exposed over the air and moisture, this coating is formed. And this leads to lead being unaffected by water. Got it? Why lead is unaffected by water? It is because of this reason. Then we see about lead that written, should I write?
yes, yes.
Lead is amphoteric. Now, what do you mean by amphoteric? Amphoteric means it dissolves both in acid and alkali. Now, when it dissolves in alkali, what does it forms? When it dissolves in alkali, it forms plumbates. What? It forms plumbates. Plumbates में क्या? It will form Na2PbOH 6. Or it can form Na2PbO3. Now, but since it leads to the formation of PbCl2. Okay. So due to the formation of a surface coating of lead chloride, lead does not dissolve in conc HCl.
Oh,
Then next is lead. Most important, lead is used in making lead chamber. Lead chamber for H2SO4 plant. And even certain alloys, like we can say tin and solder. I told you yesterday. Solder, solider. Now, when we see oxides, regarding oxides, See, regarding oxides, plumbum exists in Pb2 plus and Pb4 plus. But this Pb2 plus, this is most important, or you can say this is more stable. Now, why it is stable? It is stable again because of inert pair effect. Because of inert pair effect, and this inert pair effect actually increases the stability of +2 state while going down the groove. Got it?
Got it.
Now, so you can write down as we go down the groove. So, oxide formation of lead. Now, again, this is very important. Means lead, when reacts with oxygen, it will give what? Lead oxide, which is yellow in color. This again reacts at 380 to 420 degrees centigrade. It will give what? It will give red lead, Pb3O4. What is this? This is red lead. And again, oxygen heating, this will give lead oxide, which is brown. Okay, so at different parameters, we are getting the oxide state. Okay, now I'm sharing you some more reactions because these reactions they may give it some time. So just copy these, write down these reactions.
Okay. Yeah,
Written?
done, done.
Okay. Similarly, we see that chlorides, lead when chlorine gas is allowed to pass through it, then it forms lead chloride. Okay. And excess will form PbCl4. Now here they ask the excess part, how this will form. So if we dissolve Pb2 plus salt, okay, so we see like you can take PbO, you can take PbCO3, you can take PbNO3 also in HCl. So what corresponding product you will get? You will get PbCl2. Okay. But in this case, you see that this PbCl4, which is formed, it is less stable. And when you heat it, it breaks down again into PbCl2 plus Cl.
Oh,
Now we'll see written.
no, one second.
Done.
Just one second. Yeah, done.
Now, tell me the correct order, current covalent character. Okay. PbF2, PbBr2, PbI2, and PbCl2. Correct covalent character.
Think PbF2, PbI, like Vi2, PbCl2, PbBr.
No, means more than or less than. Tell me. Tell me in more than order. Chalo.
In more than first will be PbBr2,
First is PbBr2. Okay.
and
It is the
PB
covalent character. Then,
uh, PbCl2,
okay.
and PbI2 and PbF2.
Okay. Can you give me the reason for this?
Basically, the character will go on decreasing down the group. It will go on increasing. Sorry.
Increasing, but why? But why?
No, teacher.
First thing, this is wrong. Correct
Okay.
order will be PbI2 is more than PbR2 is more than PbCl2 is more than PbF. Okay, so what do we know? As we go from top to bottom in a halogen series, what is the fluorine is most reactive, right? Fluorine
Right.
has got highest reactivity. After that comes chlorine. After that comes bromine. After that comes iodine. So therefore, PbI2 is more having more covalent character than PbR2. And this PbR2 is having more covalent character because iodine takes a lot of time. It is the slowest reacting substance. Therefore, covalent character will follow this order. Okay.
Oh, oh,
Now last is TTEL. Do you know what is this? TTEL is tetraethyl lead. You can say CH3, sorry, CH2, CH2, CH2 taken for PB. This is tetraethyl, right? What is it? Tetraethyl. Tetra means 4. Ethyl means C2H4. So this tetraethyl lead, it is a neat question. This is used as an anti-knock additive for
oh,
increment in the octane number of petrol. And its commercial preparation is used as sodium lead alloy. Done?
yeah, teacher.
Then we see that sodium or lead, when it is used with 4 molecules of tetraethyl ETCl, you will get lead ethyl plus 4 molecules of NaCl. So therefore, for new cars, बोलते हैं ना unleaded petrol, to run lead free petrol, then tetraethyl is declined rapidly. Okay. So it was produced in large tons, but now because of its cancer producing property, it is an organometallic compound. It is now reduced. Okay. This is about TTEL. Now let's do some important questions. Done?
Yes.
Okay. My first question is, explain the nature of boric acid as a Lewis acid in water. Yes, give me answer. And second question is, explain BF3 does not hydrolyze. And second, first option, second option, carbon shows catenation, but lead does not. Answer, please.
Just 1 second. Basically, for the first question, boric acid is a monobasic acid. It acts as a Lewis acid by accepting electrons from the hydroxyl ion of water.
Okay. Correct. So H3BO3, it is what? It is a weak acid or a strong acid?
It's a weak acid.
Okay, good. Second one.
Gonna be
Yes.
yeah, sir.
What will be the second one? Louis?
Ma'am, the screen is glitching out again. Can I just join from the phone?
BF3 does not hydrolyze. Give me answer to this.
BF3 does not hydrolyze. Basically,
Yes. Hmm.
covalent character is basically fluorine का ये covalent character is too small to let the hydrolysis happen. Cannot accept electrons.
Anything more?
Uh, no, I didn't understand the question.
I am asking, explain. BF3 does not hydrolyze. Why? Why hydrolysis does not take place in BF3? We did this. Yes. Should I tell? It does not hydrolyze completely. It basically hydrolyzes incompletely. Hydrolysis means what? Whenever we react it with water. Okay. So what does it forms? It forms S3BO3 and HbF4. Got it? Neel? Neel? Ma'am?
Yes, ma'am. Sorry, the laptop crashed, I think.
Okay. Yes, tell me.
Yes, BF3 does not hydrolyze. Okay.
Hmm? Yeah,
One second.
hydrolysis, BF3 does not undergo hydrolysis. Now next is, this carbon shows catenation property, but lead does not. Why? Carbon shows catenation property, but lead does not.
Yes. Just 1 second.
Catenation property depends on what?
Catenation property depends on just 1 second, ma'am. 1 second. It depends on the atomic size as well. So the atomic size of carbon is much smaller than that of lead. So the
Yeah.
carbon bonds can be much stronger than lead also.
Mm-hmm.
Due to that, C to C bonds are stronger than PB to PB bonds. And
Mm-hmm.
then because of the atomic size and the strength of the bonds, uh,
Mm-hmm.
they will have a greater chance to show catenation property than lead.
Yes. Okay.
Yeah, ma'am.
Good. Now, boron does not exist. Next question. Boron does not exist as B3 plus ion. This is neat question. They will ask that which of the atom does not exist as a free ion. Which will not exist as a free ion. So why?
Basically, boron requires a large amount of energy to remove 3 electrons from its orbitals.
Yes.
So
So,
it does not have that much energy at all to remove those 3 electrons. So therefore, it cannot exist as B3 plus ion.
okay. Now I'm giving you one equation. A plus 2HCl plus 5H2O will give you 2NaCl plus X. Then X, when combined with HbO2, X gives HbO2 and this gives Z. So you have to identify A, X, and Z.
Mm.
This is neat question.
Yeah, ma'am, just 1 more minute.
Yeah.
Yeah, teacher. X will be H3BO3. Z will
What
be
will be A? A will be whatever. What will be A?
Na2B4O7.
What is that? Borax.
Okay. Oh, boron.
So X will be,
X will be boric acid, H3BO3.
okay, yes. Then
And
Z will
Z
be
will be boric trioxide,
very
B2O3.
good. Boron trioxide. Okay, very good. You have written all these questions?
Yeah, teacher.
Oh, chalo then. Bye. Our P block is over, right?
Okay, teacher. Yes, yes.
Bye.
Okay. Bye, teacher.